Energy. How is energy defined? Energy is defined as the capacity to do work, or energy is the ability to do work. More the energy we have, more work we can do. Less the energy we have, less the work we can do. Okay. SI unit of energy is joule and CGS unit of energy is erg. Work also has same unit, joule and erg. Energy also has same unit, joule and erg. Okay. Now there are many kinds of energy, or many forms of energy, like heat energy, nuclear energy, electrical energy, sound energy, tidal energy, chemical energy, etc. Okay, we'll study about their conversions in later in another section. But first we'll discuss about mechanical energy. What is mechanical energy? Mechanical energy is the energy possessed by a body by virtue of its motion or position. Okay. There are two parts of mechanical energy. Number one is kinetic energy and number two is potential energy. So what is kinetic energy? Kinetic energy is basically the energy possessed by a body which is in motion. Okay, it is the energy possessed by a body by virtue of its motion. Whenever a certain body having some mass is set into motion, it will have kinetic energy. So one important condition for a body to have kinetic energy is it should have motion, and another one is it should have mass. Okay. Its expression is Ke equals to half mv square, where m is the mass and v is the velocity. So if a question is asked, what are the two factors upon which kinetic energy of a body depends? The answer should be mass and velocity. Okay. Now another one is potential energy. It is the energy possessed by a body by virtue of its position or configuration. Right. So from this what we can get is mechanical energy is made up of two components, kinetic energy and potential energy. So the definition of mechanical energy is it is the energy possessed by a body by virtue of its motion or position. Okay. If the energy is by motion, it's kinetic energy. If the energy is by position, it is potential energy. Okay. Now there are two parts of potential energy: gravitational potential energy and elastic potential energy. Now what is gravitational potential energy? It is the energy stored when the body is raised above the ground and work is done against the force of gravity. Okay. Suppose this is the ground level and there's a certain object with mass m. Okay, it is raised up to the height h. Okay, and the acceleration due to gravity is g. G is the acceleration due to gravity. What will be the force acting on a body? The force acting on a body will be mass into acceleration due to gravity. The force acting on a body will be mass into acceleration due to gravity. And what is the formula for work done? We have already done this. The formula for work done is work equals to force into displacement. Okay, the formula for work is force into displacement. What is the force out here? mg. What is the displacement? Displacement is the height h, because the body is displaced from ground to this height h. So what is the total displacement? Total displacement is h. So what will be our potential energy? For first of all, work done equals to, let us revise, force into displacement. Force we have got is mg and the displacement was h. So what is the work done? Work done is mgh. But this work done will be stored in the form of potential energy. So the formula for potential energy will become, potential energy is mgh, where m is the mass, g is the acceleration due to gravity, and h is the height to which the body is taken. Okay, so if the work is done against the force of gravity, if the body is lifted up from the ground against the force of gravity, the work will be done, and that work will be stored in the form of gravitational potential energy. So if the question may come like this: what is the energy possessed by a bucket kept at the top of the building? The answer will be gravitational potential energy. Okay, in this context I have given you a simple numerical. An object A of mass 20 kg is placed at a height 2 meter and object B of same mass is kept at height 2.5 meter. Which one will have more potential energy? Look at this. Object A has mass 20 kg and height 2 meter. Object B of same mass means 20 kg kept at a height 2.5 meter. So which one will have more potential energy? First we have to write down given there are two objects, object A and object B. Object A has mass 20 kg, alright, height is 2 meter. Okay, G, it is not given out there, but let us take actually it is 9.8 meter per second square, but for our convenience we have taken 10 meter per second square. Okay, G is 10 meter per second square. So what is the formula for potential energy? Potential energy is mgh. So put the value. M is 20, G is 10, H is 2. Therefore the potential energy will become 400. The unit is joule, so 400 joule. Okay, now let us find for object P. Mass is same, so 20 kg. Acceleration due to gravity is also same. G is 10 meter per second square. Height is now 2.5 meter. Okay, now put the formula. PE equals to mgh. Put the value. M is 20, G is 10, H is 2.5. Okay, so the potential energy will become 500 joule. So which one is more among this and this? 500 is more, so the object B will have more potential energy. Since the body is at greater height, it will have more potential energy. So this is the most basic numerical which we get from this section. Okay, learn this numerical. This numerical is very, very important, so you have to learn this. Next is elastic potential energy. It is the energy stored in a body when the work is done to deform the body. Okay, what does this mean? Suppose we have one ball. Okay, if we apply force, okay, if we apply force from here, the ball may become like this. It may change its shape like this. Okay, if the ball is made of sponge, so it may change its shape. So we are doing work by applying this force to change the shape of this ball. So the ball is deformed now. The ball is deformed. So whatever work we are doing or whatever force we are applying to do this work, that work will be stored in the form of potential energy called elastic potential energy. Another example, suppose this is a spring. Okay, now we apply force from here. We apply force from here, and now the spring will be condensed and it becomes like this. Now we are changing the shape of this spring. Okay, so whatever work we have done to change the shape of the spring or to deform the spring, that work will be stored in the form of elastic potential energy. Okay, now our next topic is transformation of energy. So what is basically transformation of energy? Transformation of energy means to convert one form of energy into another form. For example, when we switch on the light, okay, the electrical energy is converted into light energy. If there is no electrical current, or when there is no supply of electrical current, we cannot switch on the light, isn't it? So to switch on the light, we need electrical energy or electrical current. So at that moment when we switch on the light, electrical energy will be converted into light energy. Sometimes it will give us little bit of heat, so there may be little bit of heat energy also out there. So before doing or before studying about the transformation of energy, we have to learn one very important law. Okay, that is principle of conservation of energy, which states, principle of conservation of energy states that we cannot create new energy nor we can destroy it, but we can transform it from one form to another. So what does it say? We cannot create new energy. In that previous example, when we switched on the light, okay, the bulb starts glowing, but did we create that light energy? No, we did not create that light energy. We simply converted the electrical energy into light energy. No one can create new energy. Okay, when you rub a hand, you will feel that the heat. Okay, when you rub the hand, you will feel the heat. So where is that heat energy coming from? You are not creating heat energy at that time. When you rub a hand, your hand will be heated, and keep in mind, you are not creating any new heat energy out there. You have just converted heat energy from the mechanical energy. When you rub a hand, you set a hand into motion, and we all know when the hand is set into motion, there is kinetic energy, and kinetic energy is a mechanical energy. So we waste that mechanical energy to create a heat energy. Okay, this is the principle of conservation of energy, which states we cannot create new energy, nor we can destroy, but we can transform it from one form to another. This is very, very important law. Few examples. Loudspeaker. Loudspeaker, we basically call sound box locally, isn't it? Loudspeaker, it converts electrical energy to sound energy. Rubbing a hand, as I said, mechanical energy to heat energy. Windmill. Okay. Okay, suppose this is these are the blades of a windmill, and this is a windmill, pole of a windmill. Okay, when this blade starts rotating, okay, what type of energy it will have? It will have mechanical energy, because these blades are moving. It will have kinetic energy, and kinetic energy is a mechanical energy. It will generate electricity. These windmills are used to generate electricity. So what is happening out here? Mechanical energy is converted into electrical energy. All right. Out here we can see mechanical energy to electrical energy. There are many more examples, like in candle, chemical energy to heat and light energy. Okay. When vehicles move with the help of petrol, what is happening out there? The chemical energy of a petrol is converting into mechanical energy. Okay, you must have seen the trains which runs with the help of heated coal, isn't it? What happens out there? The heat energy of coal gets converted into mechanical energy. Okay, and there are many more examples. You can simply learn it, you can check it in a book, or you can Google it. All right. Our next topic is power. Power is defined as the rate of doing work. Okay, power is defined as the rate of doing work. Its formula is P equals to W by T. Power equals to work by time. Its unit is, okay, the unit of work is, first let me change this. All right, the unit of work is joule. The unit of time is second. So what will be the unit of power? Unit of power will become joule per second. Okay, the unit of power will become joule per second, but in short we can also say it as watt. The unit of power is joule per second or watt. Okay, so power basically means, suppose there are, I'll just give you one example. Suppose there are two persons A and B. Okay, if they are doing same work, he is taking 10 seconds, he is taking 5 seconds. Okay, who will have more power? This person will have more power, because he has higher rate of doing work. Okay, he is doing same work in less time than this person, so he will have more power. That's why the definition of power is rate of doing work. If you have higher rate of doing work, you have more power. If you have lower rate of doing work, you have less power.